You know how an electric motor converts the electrical energy it draws from a battery or mains supply into mechanical energy. Can you guess what an electric generator does? The electric generator does the opposite of what the electric motor does. It converts mechanical energy into electrical energy. Let us see how it does this. Electric generator works on the principle of inducing an electric current by rotating a coil in a magnetic field. A rotating rectangular coil ABCD is placed between the two poles of a permanent magnet. The two ends of the coil are connected to the rings R1 and R2. R1 and R2 are insulated on the inner side. The brushes B1 and B2 are positioned such that they press on the rings R1 and R2. The axle can be manually rotated from the outside to rotate the coil inside the magnetic field. Alternatively, an energy source such as diesel, flowing water or wind can be used. The outer ends of the two brushes are connected to a galvanometer to show the flow of current in the given external circuit. The axle attached to the two rings is rotated anticlockwise. Arm AB moves up and the arm CD moves down in the magnetic field. To find the direction of the induced current, you can use Fleming's right-hand rule. The direction of the induced current is now ABCD. This means that the current in the external circuit flows from B2 to B1. If there are more number of turns in the coil, the current generated in each turn adds up to give a larger current through the coil. After half a rotation, arm CD starts moving up and AB moving down. The induced current now flows in the direction DC-BA. The current in the external circuit now flows from B1 to B2. Thus, after every half rotation, the direction of the current in the external circuit changes. Such a current that changes direction after equal intervals of time is called alternating current, abbreviated as AC. The device that helps generate such an alternating current is called an AC generator. Can you guess how the DC generator would be different from the AC generator? For Fleming's right-hand rule, hold the thumb and first two fingers of the right hand in such a manner that they are mutually perpendicular to each other. The thumb indicates the motion of the conductor. The index finger indicates the direction of the magnetic field. And the second finger shows the direction of the induced current. Hold your right hand between the poles of the magnet within the generator in such a way that the index finger points in the direction of the magnetic field from the North Pole to the South Pole. The direction in which the second finger points is the direction in which the induced current flows. The thumb shows the direction in which the conductor moves. This rectangular coil, ABCD, is made of many turns of wire wound over a soft iron core called the armature. The armature is placed between the poles of a strong magnet. The brushes B1 and B2 are in contact with the split rings R1 and R2 of the commutator. R1 and R2 are connected to the arms CD and BA. The commutator is a slip ring that can be slipped on the axle of the generator. The slip ring is formed of two split rings of conducting material, separated by insulating material. When the coil rotates, then arm AB will move downwards, and arm CD will move upwards. The current will flow in the direction DCBA and onwards to R2. Externally, this current flows from B2 to B1, since R2 is in contact with B2. Now the coil takes a half a turn, and brush B1 comes in contact with R2, and brush B2 comes in contact with R1 of the commutator. The current now flows along ABCD and onwards to R1. But externally, the current will continue to flow from B2 to B1, because B2 is now in contact with R1.